Hello and welcome to another episode of Talk3D. Today I'm very excited because I have John Phillips here from the University of Guelph, and he's going to tell us what he does there.
Thank you for having me, Ken. I've known you for quite a while now, but I'm not sure how much you know really about my background.
Not too much, actually.
Yeah.
You're way more exciting. We just talked a little bit before, but you're way more exciting than I thought you were because, I mean, you were exciting before, but you have a lot more background to tell.
Yeah, no problem. Interesting background. Started off kind of in the mechanical engineering side of things, actually in mining engineering at one point.
Okay.
Switched through my career and eventually ended up in more biomedical applications. And stayed in school way too long, got a PhD in that area within engineering. And through my experiences, I was working for a professor who was in the environmental side of things, and he had a design chair position within Canada at the University of Guelph. And we were working on all sorts of interesting problems. We were actually working a lot on pedagogy, so education. He was one of the first people that introduced a lot of like the higher level CAD design within our design program.
Wow.
And through him, I convinced him to buy the first 3D printer at the University of Guelph. We won't talk about how long ago that was.
I was going to ask you, like, how long was
it was a long time ago. And at the time, they were quite expensive.
Right.
It was like, you're talking a 5-figure to 6-figure purchase. And
sure.
So we ended up.
And was it an FDM printer at the time?
It was an FDM printer. It was an
Okay.
ABS printer.
Okay.
And we were able to implement it into the design curriculum and kind of having that bottleneck of one printer at the time, but we made it work.
So how did you convince him though? Like, was it like, hey, there's this new technology, we have to get involved? Like, what did you see in it that you thought it was important enough to convince him to spend that money?
What he wanted to do, and he was really kind of a supporter, though he didn't have that background, was in the computer-aided design and the ability for students, to generate and to produce ideas on the screen.
Right.
And I think my selling point was instead of simply machining objects and the logistics that would have been involved with that would have been impossible, the idea of being able to bring students' ideas to fruition and that ability to 3D print that part that's on the computer and have that student also experience that things don't always work the same way that they are on the computer. Right. And so we were able to kind of work with that in a stepwise way. I was also working a lot on research projects, and I knew how beneficial that would be to working at ideas and concepts and to have those actual objects that you can test, feel, experience, and then be able to implement into your designs.
So it was an exercise in enablement for your students and for you and in your design lab in order to get things done quicker, faster, in a different way, right?
Exactly. And different materials, you just basically, you're relegated to plastics for those types of printers. But plastic's a wonderful material. It's very versatile. It's very useful. And even beyond that. So that's kind of where the beginnings of where kind of my background in computer-aided design and 3D printing started. I was also introduced to an artist early on. And this faculty member artist ended up at my door one day, was looking for help on a problem. And they were doing an interesting problem where they had these photographs of Cold War Soviet era satellites. And it was some of the first satellites that were produced that went up.
Wow.
And he wanted to create a life-size model.
Okay.
And so we're looking at different materials. A lot of it was sheet metal. There were some 3D printing components, all those different things. And I remember at the time asking my boss, who was in the engineering department, I said, hey, should I help this faculty member? And he had this very open idea of saying, hey, this is somebody on campus, we should support and help them as well, and especially on their design ideas. So that ended up starting this long relationship between the arts department and myself through this faculty member, and we created our own lab. And that's kind of where I'm sitting now. It's called the Inter-disciplinary Design Lab, where we have basic manufacturing capabilities. A lot of it's software, because it's always about doing the digital designs for your objects. We have a number of 3D printers that can enable the building of those ideas and the testing. And it's truly interdisciplinary in that at any point in my lab, I might have an architect, an engineer, a scientist, an artist, all kind of rubbing shoulders and working together and being able to share ideas, seeing what they're up to. And everyone else has their own backgrounds, their own expertise. And you're able to really kind of create this really nice group of people where we can bring a lot of different ideas to fruition.
Yeah, that's so interesting because interdisciplinary, I mean, you're in the Department of Fine Arts, which is almost, unexpected. When I first talked to you, I'm like, you're an engineer, you talk like an engineer, you're very engineering based, but at the same time, we have all of this interesting different elements from bio. And I think that's why you touch so many different types of technologies, processes, and you're not really stuck to one thing. Like, we're not just gonna machine it, we're just not gonna 3D print it. You really do a whole bunch. So in terms of this lab that you've created now, you've obviously been enabling even more people to work with you and your team. Tell me a little bit more about your lab in terms of who you work with and also who is coming to you for help.
It's a great question. It could be a myriad of different people. Where its current project right now, I'm working on a large art project where we're producing this green space, which is it may have some components that may be 3D printed, especially some of the conceptual designs that we'll do. And it's basically a walk-in green space. It's gonna have plants. So we're creating a sense of wellness of basically, what do we call it? Green space environments have been basically associated with walking in the woods, forest bathing.
Okay.
That whole idea of wellness on that level. So we've got different groups working on creating that. I'm working with another group where we're looking at basically purifying or filtering water coming off of a hydroponic system. That's an interesting project. We've got so many projects going on. And
so with some of these projects, what are the parts that you guys are actually working on to help solve? Like, is it a technical problem, or is it a design problem, or is it both? Like, where is it that they're coming to you and going, okay, you guys are the specialists, you guys have all of these tools. What are the types of problems that you get specifically?
Exactly. I think it's the core of what I do is problem solving.
Okay.
And it's on all those areas that you just talked about. So it could be materials, could be applications, could be processes, could be the manufacturing method that we're going to use all the time. Mm-hmm. I'll get researchers sometimes that'll come in and say, hey, I want to 3D print something. And immediately I have to almost back the conversation back to what's the problem you're trying to solve. You're telling me how you want to solve it, but please let me know. And then we can decide from there what might be the most applicable kind of technology to get you where you want to go. And yeah, 3D printing is amazing, but sometimes you need to machine a part. Sometimes you may need to incorporate something like a laser cutter. Maybe you need to incorporate a water jet cutter because the material just isn't applicable for a laser. EDM, all those different things. There's so many wonderful ways to make things.
Yeah.
We always said if the budget was infinite, then that makes it a little easier because these things also cost different things.
Right.
Some of them are, your own sweat equity, your own labor, maybe just chiseling away at a part because you have no budget for the project, or it may be something that would cost many thousands of dollars to machine an object out of titanium or something like that. Or even metal printing, something like 3D printing out of metal, which is possible. It has its pros and its cons, its limitations and its benefits. But that's that possibility that can happen now.
I'm going to come back to cost a little bit later because that's going to be a big thing for us to discuss.
Yeah.
But in terms of keeping up with technology, I mean, you've talked about a lot of different technologies and things that you've been working with. How do you yourself, as also like kind of the head of this interactive design lab, how do you keep on top of all of this technology that's both emerging and, we've known in the past? Like, and how do you decide to guide your clients, to which technology? So how do you yourself keep on top of everything?
That's a great question. As a designer, a lot of times what I want to do, especially if I see a new piece of equipment, I actually want to operate the piece of equipment. I want to understand the full process. I want to load the printer with material. I want to see how it is to calibrate it, all those different things. And then I'll get samples of maybe parts that we've already done if it is a brand new technology, and I'll be looking for things like the strength, the surface finish, the cost, basically how robust the parts are. But I'm a firm believer as a designer, you should understand, I'm not necessarily saying to be a designer, you need to be a machinist, but you need to understand how machining works, what a machinist does, how materials are different, how they respond. Because you may spec a certain material understanding that some are more difficult to work with than others. And you really got to look at the pluses and the minuses. You can't build everything out of titanium, and not that you'd want to. There may be other materials which are going to be much more applicable given chemical characteristics, strength, all those different things that you got to bring in. And I think understanding when to implement what is you have to do. You have to make things. If you're really interested in design and those things, my first thing is just start making stuff. Start looking for problems to solve potentially around your house. Could be a doorstop, make yourself a custom doorstop. And don't be, I know maybe a good starting point maybe to go on, say, Thingiverse and download it. You're not going to learn a lot about how to make something by downloading a part. It's really learning the software and learning how to use those tools to bring your own kind of problem solving and your own ideas to fruition. And the only way to get good at those things is doing. You have to keep doing, making mistakes, being rewarded by doing successful designs. You'll make mistakes a lot of times. You'll be throwing parts out. You will be changing things and iterating. That's the beautiful thing about 3D printing. If you had one, you may be designing a part and you may build it 4 different times, testing it, checking out how it's working, making a slight adjustment, then 3D printing it again, making it better and better and better to the point where you're completely satisfied. And that's really one of the big benefits, if you can afford or to have or access to a machine, is to get that really quick cycle time through in your designs. That really keeps the flow of creativity. It really keeps the flow of problem solving really nice. You're not waiting, you come up with an idea and you're waiting 2 weeks, to see what the solution is or how well your part's going to work from the computer. And I think that was many years ago, that was the way that design work was done. You're designing things and you may wait multiple weeks to months before you see the parts. And
you hope it's right.
And you hope it's right. One time I had to build a part that was for injection molding, and it was a part that actually had to snap together. You're doing all those calculations, the tolerance fits. It has to be almost perfect to get like a snap fit on a custom part. And there's a lot of pressure. You're designing this part, it's going to go off. They're making a mold, which is going to cost 5 figures.
Yeah.
And then they make that mold, and then all of a sudden, you get your first run of 1,000 parts or 2,000 parts. And that eureka moment of it works. Yeah, with all the calculations, but it's not taken lightly. There's a lot of planning, checking your numbers, making sure that everything is and also the experience. It's hard to do that when that's the first thing you've designed. If it's the 1,000th thing you've designed, then that's a little bit easier. And it gets a little bit easier as you earn the confidence that you're going to build as well by doing that.
So there's a couple of things I took away from that. And definitely one is self-learning and education. You just got to do it, try it, learn it, actively learn it, try it, and don't just, print for the sake of it, but learn, what the results were and measure that result and compare it against what you expected. Yeah. And the other thing I heard was a lot about limitations, right? And we talk about limitations a lot for 3D printing, but let's talk about the time restraints that you have. I mean, you have a lot of technology, so, the technology is there, so you don't have that constraint, but you must have some time and money constraints. Can we talk about what kind of time constraints you run into? Like, what do people put on you, in terms of figuring things out, and why is it so important to have some of this equipment in-house versus having a service bureau? Because now there's a lot of opportunities for service bureau work, and there's even more expensive machines out there maybe that you don't have. So why would you choose to have some of this in-house?
That's a good question. And like anything, I actually don't want to have every piece of equipment in-house, because like anything, it's going to require maintenance. The parts are going to break. It's going to also get to that idea of high liability. Some of the machines that we use, you got to print with them every week. Yeah. And the material may be $1,000 a liter. And so
it could expire if you don't use it.
And it could expire, and you're running into all those issues, and you're basically throwing away thousands of dollars. So I think having stuff in-house is amazing. It's the right technology. A lot of it is we're doing early proof of concept. We always had this philosophy. We don't mass produce things. We figure out solutions to design problems. And then once we figured that out, there's an amazing network of companies, solutions, or service bureaus, solution centers that we can order 100 parts, or, and depending what technology. It's mass production is something that industry does quite well. But that kind of early on in a design team, fleshing out designs, and you don't need anything that's overly fancy, I think, to work out those initial design problems. You need decent tolerances on parts. You need the robust, the ability to get inside. Typically, when you're making things, it's usually within this commonly small build volume. You can have a huge printer. Typically, people aren't building giant things all the time. A lot of times when we work, at 99% of the time, you're building something and it's quite small, the size of a fist, or around that size.
Would you prioritize like the speed and iteration cycles versus like just having the flexibility of a large build volume?
That's a good question. For what we do, it's nice to have, because we get a variety of different challenges and problems. We do run into it being like nice to have that printer that could build the size of a car bumper if we wanted to. That'd be amazing, because we do run into that every once in a while. instead of building it in like 10 different parts and putting it together. Could be, we would love to have machines that had, 5/1000th of an inch accuracy across at all times, but those machines are quite expensive. And
do you really need that?
And you need that all the time. That's another, actually, that just made me think of something too, is sometimes a hammer is required or a saw. And if you have all the equipment in the world, sometimes you overanalyze what you think you need to do. Sometimes you should just go over and instead of 3D printing a plate, maybe just drill a couple holes in a plastic plate. That's going to be a better solution. And so it's really that balance. We'll do a lot. Honestly, like a 3D printer or a laser cutter can be a really good balance. And we incorporate the two a lot. We'll figure out what can be 2D and then cut out quickly, say in that technology, and then what can be 3D printed, and then combine the two. Instead of I do this all the time, instead of trying to stick to one technology, because they both have their limitations, but they can really complement each other.
So you really are a master of that lab in terms of knowing all the equipment, knowing the processes, and this is what you were talking about, playing with everything so you know what is good to use for whatever process you want to get at as quickly as possible.
It's true. And as quickly as possible, the nice thing with a 3D printer is it's not something that you have to babysit. There's kind of a nice feeling at the end of the day. You spend your whole day designing, and then I go and I upload the print job. And then that night while I'm sleeping, my part's being built.
Yeah.
And I almost feel like I'm still working.
You should still be paid.
The machine's working for me. And then in the morning, you've slept, you had all those design cycles going through your head, and you have that part and you're testing, and you can start the design again. It's pretty awesome to have that kind of a nice design cycle. And it really is a great feeling when you have control and you're printing your part. It really is, you still feel like you're being productive even after the point of you touching and working on the design.
So I always kind of call you spoiled because you have access to all of this equipment. But how do you decide, how to choose, a piece of equipment? Because you said you don't want every piece of equipment in the world. Makes a lot of sense. So how do you decide, hey, you know what, this might be good to have, or this might be good to service out? How do you decide to bring in a piece of equipment to your lab? And what are some of those considerations?
It's a really good question. I think any kind of workspace or design and prototyping, some sort of FDM machine. So the old school fused deposition modeling, melting, a filament of material. That'll be your workhorse. That'll be kind of the backbone. Reasons being the material cost is really inexpensive. Design limitations, if you can get a dual one with support material, then you can really safely get into organic designs and those different things. And it'll service a large portion of what you need.
Right.
When you're getting into close fitting parts, slip fitting and those kind of things, then you're moving into other technologies such as the SLA. For the longest time, one of my favorite technologies is SLS. It's the closest that I can get to a really isometric properties, really durable parts that are as close to injection molding. And the idea that your support materials, you're basically blowing off the support material. You're not spending a whole bunch of post-processing time adjusting a part due to the supports. It's basically what you design is what you get, assuming the machine works well. We've also sent out jobs, you get thermal distortions. Nothing is perfect. Right. And, but understanding that there's also, I guess, that understanding too is designing. It just made me think of something as well, is that idea of designing for 3D printing is really important. We haven't really talked about that too. So when I design something for 3D printing, it may be different than designing for injection molding. It'd be different from designing for machining. Understanding what the machine's limitations are. Some of these technologies don't like thick, bulky parts. Number one, they cost you a lot of money. There's a lot of thermal energy in those parts, which could cause distortions in their own.
And the time.
It exponentially increases time. So if you're a traditional machinist and you get into 3D printing, it becomes the opposite because you think about how a part needs to be built. But when you 3D print it, the rules are kind of out on certain areas. You can build things that are impossible to machine, which is bad for mass production because you got to think about, okay, if I do need 10,000 of these parts, how do I translate my design to say be injection molded or cast or in those different ways? We are now entering an era of mass production of 3D printing though. I've bought products where you could see that they were close to market and I can tell one of the parts was 3D printed.
Yeah.
And maybe they just needed a short run of 10,000 or 1,000 parts. They had a print farm. They're able to make that part and that gets them to market sooner. And the market itself may be okay with that kind of almost pre-mass production part to get that product. It's interesting with supply chain issues right now. getting things shipped across the world for the first time in a long time has become an issue. And with a 3D printer, you've got a manufacturing facility potentially in your own in your own company, in your own production house.
And I think we see more of that, with 3D printing companies more than anybody else because they make the machine. So a lot of times they'll tend to want to use some 3D printed part inside the machine as well. Some people like that, some people don't. But it's definitely a viable option, at least for them, if they're not producing 100,000 printers at once to have a short run with their own equipment.
And that's a testament to what they've been able to do with the materials. A 3D printed part is generally not going to be as good as an injection molded part or the material properties, all those kinds of things. But they've gotten better and better. Some of the durability of the SLS parts that come off of machines, they pretty much could be put in.
Yeah.
The other thing too is I know with young engineers who always think, I always say when I walk into a design meeting, we talk about building parts and producing into things. I see, say, young designers say printing a gear. And I'm like, a gear costs 10 cents, are built in a certain way, are a highly tolerant, specific piece of thing, not necessarily the best thing to 3D print. Unless it's some sort of bespoke giant gear that doesn't exist and you need some sort of gear ratio that's unique. A lot of times it's boring, but sometimes you should just buy off the shelf. Sometimes you need to just go and buy a bolt.
And I think that's really expertise speaking, someone who's seen a lot, done a lot. But I want to come back to what you said before, which was a little bit about the software designing for 3D printing, which is almost a specialized skill now because the 3D printing technology is getting a little bit more robust, so you can do more with it. So there's three elements that I've pinpointed out. One is to design for 3D, which you've talked about. One is the 3D printing aspect itself or the manufacturing aspect, whatever tool that is. But the last part is getting to mass production. And I think, a lot of the conversations that we have, we kind of stop just before that part. We're talking about short run and that might be good enough, but you've had experience going from, let's say, 3D printing prototyping, short run, all the way to mass production. So how do you find people are bridging that gap, and how are you bridging that gap? What do we have to do differently from the prototyping phase all the way to the mass production phase?
It's a good question. I've seen, my inclination right now is 3D printing on a mass production level isn't ideal because of the restrictions of the manufacturing process itself, and the materials that are applicable to that can be 3D printed. If you look beyond that, say into an injection molded part or whatever, you're opening yourself up to so many more thermoplastics and different designer materials, which may be more applicable for a project. I think it is knowing when to go from where. It's almost, there's a question sometimes, say, with laser cutting and water jet. You say, well, when do I water jet cut apart? When do I laser cut apart? And it comes into a myriad of questions. How much thermal energy do you want to go into the part? Because laser, you're basically throwing a lot of heat and energy at it. Water jet, you're vaporizing a part or a material. And there are calculations there. This is where it gets into almost the manufacturing engineers and those people. And where your return on investment, the quality of the part. But again, speaking before, I think the 3D printing is just going to dominate that space for prototyping, though. It's even in an automotive space. It's being used all over the place. You can essentially, have custom designed 3D printed parts that are painted up and those things that may go on to their prototype cars that someone could be driving around.
Yeah.
They're not going to go off and maybe traditionally machine it. Big one with the automotive companies and those other companies, they figured out a long time ago, the idea of fixturing. Fixturing is a huge aspect. And then they realized that the 3D printers have the accuracies that can be used for fixturing. Same thing, if you've got a bunch of printers in-house, you can control, your engineers can design the fixturing components, those can be put in. In arts, we do this all the time. I gotta drill a hole specifically exactly in this organic shape. My solution right there is I've got a digital model of that. I can make a custom placement fixture. I can put in, and again, this is where you use the best of both worlds. You 3D print and you make an access point for a drilling dowel or a drilling insert that can go in, and then I can drill and use that 100 times.
Yeah.
We do this all the time with 3D printing where we'll incorporate other components. You make a spot where you're gonna put in a steel nut so that the screw can go through and you've got that 3D printed component. It's got the backbone of a steel embedded nut, the screws going in. You've got basically a screw going into a steel nut, but the print itself is plastic. And we do that all the time, incorporating different off-the-shelf components where they're needed. Not to say we also 3D print and then we'll basically be able to make a thread into the plastic part, because maybe all you do need is a threaded plastic part for that application.
Yeah.
And you wouldn't maybe try to print that thread, though some of the technologies that you have can print half decent threads. You could maybe take a tap and just clean them off, and they'll be beautiful, beautifully useful parts.
I'm just astounded with the amount of expertise you have. The students who come to your lab must be learning so much practical stuff, in terms of solving problems. At least they should be really paying attention, because the solutions and some of the things that you're talking about right now probably takes years to accumulate that experience of solving problems in order to get. So how are students absorbing all of this from you? How many of them, come to you with a problem and then learn so much that you've almost changed their path? You must have a lot of experience with this.
That's a really interesting question. And it dives deep into the idea of experience and practice. And we have a lot of great students that come through, and a lot of them do absorb. I tell them I'm going to talk a lot, and I'll maybe over-explain something because they may not know their background, how many things they've built or what tools they've used, what they even know about is possible. So I try to do my best to explain deeply what I'm doing and why I'm doing it. As a designer, I think it's really important to not be afraid to be wrong. I've seen this a lot with designers where I've even had people come up and say, just 3D print this for me. I'm like, hey, what are you doing? They go, what is this part for? And there can be this risk of they don't want to talk about it. I'm not sure if it's a risk of being shown that they did it the wrong way or this or that. And I think to be a really successful designer is to have that to kind of check openness, but also to check the ego. Like, people know more than you do sometimes. A lot of people know a lot more about design than I do. And I look at that as I want to learn from them. And I want to learn from them so that I don't have to make all those mistakes to learn what they know. And that's a tough thing to do. When someone's telling you something because this is what they found and they can explain how they got there, the ability to learn that kind of top level learning without having to fail 100 times to get that wisdom, I sometimes refer to that when someone tells me something like that. I even tell them, I said, you just gave me gold. That information to me is gold.
Yeah.
It's years of experience. It's them trying different technologies. And then they just told me this thing that is worth umpteen hours of my time to try to get there and all those experiences. I think it's also a comment too, is to understand when people are in different fields, say it be graphic design, be it in, say someone's really good at animation or things like that. They understand some really cool pieces of software or how to finish a part completely so it's got a beautiful polish on it. You don't have enough time on this earth to master everything. There are certain people that are going to spend a lot of time understanding and delving into certain technologies, and the ability to be able to at least take an ounce of what they know and apply it to your own skill sets. That's kind of cool, because you may not have time to go off and become a machinist, but you can understand how a machine works, or a CNC machine. You can understand those capabilities, maybe dabble a little bit into that technology, and then talk to a machinist that has 30 years experience, and they're going to be able to tell you all sorts of stories. Some of them, they can walk into a shop and they just hear a noise and they're like, that cutter is cutting that material wrong, or something's wrong. And they just hear the different way the material is interacting with the material. It's amazing, but that's just a ton of experience understanding your materials, your cutting, your tools, and how they all work.
I think you just encapsulated higher learning in a nutshell, right? You're going there so you can talk to people with this tremendous amount of experience and hopefully understand enough to just absorb what they explain to you, because it's gold, right? It's years of experience that you don't have to live through again in order to progress things even further. But I want to change gears a little bit. Okay. We haven't talked about this at all yet, and I know you probably are dying to talk about this, and that's 3D scanning. Oh. You've had a long history with 3D scanning. Where have you come from, and where are we now?
That's a really, really kind of awesome question, because 3D scanning is so powerful. That ability to basically analyze the real world in a digital way. It's almost like sound recording. I'm sure when they figure out sound recording, to be able to digitize, capture and digitize, and we went from analog to digital and all those kind of things. My early experiences with scanning, I was actually within my PhD work. I worked a lot on shoulder biomechanics, and I spent a lot of times in the basements of the U of T anatomy labs dissecting human beings and looking at their shoulder joints.
Right.
And we used an old white light scanner, Steinbeckler. It's a huge German company. They designed some of the best scanners in the world. talking a 6-figure scanner, cost to do like a short run of basically analyzing. So we looked at the surface shapes of these cartilaginous surfaces, analyzed them, and then I fit different shapes to them. Was $10,000, to do up some scans for that, and that was a deal.
Yeah.
And then also because you're dealing, I remember at the time it was like 500,000 data points to collect that surface, and that's what you had. You had XYZ data points that you then had to try to figure out how you were going to turn that into a surface to analyze. These were all huge, complicated issues that you needed really expensive software to challenge and to do those problems. Even do Boolean functions of, say, an STL file to subtract things that are now trivial, where you needed highly specialized software to get you there. So I hate talking about back in the day, but what it is those tools which were really kind of inaccessible. They were really for elite manufacturing and those things. Even as we think about 3D printing, it goes back early into the 70s when you get into stereolithography, even metal printing. This is not a modern thing. What it was there was equipment that was very specialized. Patents were really kind of restricting, who had accessibility to those pieces of equipment. So the same thing with the scanning. What I'm amazed now is, for a trivial amount of money, it could be even a couple $100s for some scanners, to even awesome scanners that cost just a few $1,000s to maybe $5,000 are the equivalent of these 6-figure machines.
Right.
It was only a couple of decades ago. And we're really limited in what you can do. The amount of data too, with computer advancements and things like that, it is kind of awesome.
Yeah.
And this is where you get even animation. I think they're the ones that are really kind of pushing that digital, that wave front of what is possible. It's the digital animation people and those kind of things, because they're pushing the GPUs, which is helping out the CAD people, because that's where all the great advancements are happening.
Yeah, I think, I've seen animation now. You don't have to wait as long to animate. You don't have to render anymore. It can be live animated. And a lot of that is bringing in that digital telemetry back to them so that they can further that even more and make it even faster. So in terms of, where we are now, obviously software has come a long way to making things a lot more usable. Back then you were in a very specialized program to do this. How accessible now do you think it is for regular students or for faculty or for the general public, in terms of having some of these scanners? And are there practical applications for regular folks to learn some of this?
I think that's a great question. I think you see places like libraries are starting to bring in 3D printers, so it becomes like a public space. There's different areas. There's maker spaces, which are in basically any town you can find, generally have a makerspace or one which is in driving distance. And it really becomes a community that comes together. I think what I've noticed on the educational side of things is what I'm seeing a lack of is the background of people in this area, because it is kind of hasn't been used for decades and decades. So you can maybe get a 3D printer and put it in a classroom, but does that teacher have time to understand that technology? Does that teacher have time to troubleshoot the machinery? Does that teacher have time to become a digital designer now? Kind of I know what it is to become a digital designer, and it didn't happen overnight. I think there's a worry that we look at these technologies and we think of Star Trek. We think of it as a replicator.
Right.
I'll show a really cool design, and I really think even high-level PhD researchers, some of them I do believe think that there was a button on the machine that was the part that I just built.
Right.
I think there's this idea of we need to educate that these are competencies to be learned, similar to the idea of making fine furniture. It's learning the tools. A 3D printer is a hugely useful piece of equipment, but to do the digital designs, to make parts, that's still the same. Understanding tolerance and fit, how things work together, understanding materials. The printer doesn't help you with that.
So how do we proliferate this further? I mean, there's more courses for 3D printing. A lot of them are very introductory, but how do we pass on, knowledge that you have to make a next generation of John Phillips who, is able to, further your lab even more and delve into technologies that even you haven't even thought of yet that might be coming in the next couple of years?
I think we're getting there, and I've seen it with some of the students that have come into my lab. I've got this great student right now, and given access to these technologies, he's really run with it. He's really he loves the process. He loves creating and designing. And I think this is why it's a nice aspect to the arts. engineers like to problem solve and design and build things. Artists are similar. They like to create and do things. So beyond like stereotyping it into certain fields, it's people that want to create, that are creative. And they can be from a variety of fields. These pieces of equipment and the software, I think there's also the different types of software that are out there. And it's never going to be as easy as totally painless. There's an idea some people just hate, the interface, would never want to use like an Excel spreadsheet, but it can do so many great things for you if you can get over that that worry of using it. Same thing with the CAD software. I think it is this access. I think it's people within the field. I think it's also people understanding and respecting that it isn't trivial, that we do need to bring experts in the field, that we need to figure out that there has to be core competencies. It would be like somebody trying to teach French to students. If they can't speak French, those students are not learning French that well. And I think it's the same thing with 3D printing. We could have all the wonderful tools in the world in front of them, but if we don't have somebody slightly guiding that, though as I say that, there are so many resources on things like YouTube. YouTube's changed everything. Like, there's tutorials. If you really want to deep dive, there's some amazing educators. I think the young engineer that I was talking about that's in my lab, they spend a lot of time even doing, say, those tutorials, practice parts. Keep making parts, thinking how to make it. You're building those neural pathways. You're learning all the tools within your software package. It's like anything. A software package that's for computer-aided design is going to have a whole bunch of tools. At the beginning, you're not sure how to use all those tools, but as you make parts, you learn how to do that best. And some of these online tutorials will have an expert showing you how they maybe made a part, what tools they incorporated, and you have that eureka moment of, oh, that's why I use that tool to do this. And then that opens up a whole new level of how to make a part. And as someone, my background too in elementary schools, I loved arts, I love painting, I love drawing, I love all these things. And as I'm now, a lot of my palette is the computer, are these design tools. And someone was saying, oh, when you retire, do you think you'll get back into painting? And I'm like, I think I really love what I'm doing now. It's not really that different than, it's just a different level of creating. Yeah. And it's not a brush in my hand. It's a keyboard with an electronic interface, but it is simply the same thing. It's a conduit to create things. And there's amazing things I can do once I understand the software and how to build parts on that digital stage, and then also understand how that translates to the real world.
I think this is why I'm so excited to talk to you, because you bring in that mix of the arts, and I think that's something that we very rarely talk about in 3D printing. We very much talk about engineering, tolerances, things like that. But the creative portion, we don't really touch on as much, and that's a huge part of what you do, is both creating and problem solving together in order to make something awesome. And let's talk about some of the art pieces that you might want to highlight. I mean, what has your lab helped with in terms of art pieces that we might know about, or can you describe and show us, what it is that you've worked on, and what are some of those challenges for a project like that? Because it's a lot more than just solving one problem, right? It's a whole project that you guys handle.
And that's a really great question. The art projects that I've worked on are some of my most proud kind of projects that I've worked on. I always say I work with different fields. I've done projects for NASA, European Space Agency, many different engineers, different companies, different researchers in a whole bunch of different fields. The art projects are generally the most challenging because artists typically want to push the envelope of what is possible. They will typically want to use materials that maybe are not standard that you might use. As an engineer, the most logical or possible solution that I may come up to a problem may not be possible because it compromises the vision of the artist. So you have to think kind of around, okay, normally I would just do this, but I can't do that. So how am I going to do it?
That's the practical way, and then
there's
there's
the practical
the
way,
artistic way.
and then there's how do I make this thing hang without any supports that's going to be 10 feet tall, that's impossible to do. Well, we got to figure out how to do it. And so that's on the art side, they're awesome projects. One of the big ones that I can maybe talk about that which you may have seen or heard about was I was on a project working with an art team that developed a chandelier for Square One. So in Square One in the food court, there's a big dome. And this is a project a number of years ago, highly challenging, this huge, I think it's 30 feet in diameter, has 3,000 DMX controlled LED lights. So it can kind of come in and out of like looking like a cuttlefish almost. very ambitious project. But at that point, you're dealing with a huge team. You've got, structural engineers. You even bring in the company that's potentially the fabricators, and you're even bringing in the company that is eventually going to move the components to the area. And there were aspects of that where we did a lot of digital file work. So you basically, every screw, bolt, nut, wire is digitally created before you even start making the first component. You make sure that the whole thing works in a digital world before you spend the money to fabricate things. But even with something that big, it was so huge, we literally did scale 3D print models of the loading bays and the sketch out to the mall area to figure out how we could even get components in.
Yeah.
So there's always this adage when you're building something, especially big, measure the door to the room and the escape to the building, because literally people will build things that they can't get out of the room that they're building it in. And
it's embarrassing, but like
you learn that once, and then you figure out, okay, this is the maximum size we can build something to get it out of the room. And so the same thing with this giant sculpture. Had a lot of different problems. One of the ones where 3D printing was a really immensely useful tool was these lights that we had. You could buy them, and typically what you would do is you just screw them into the wall, but we had this stainless steel structure, and we had to figure out how to mount 3,000 of these. So one is, it can't be too laborious. You can't be drilling all these holes because it'll affect the structure. So we came up with this mounting system to hold it, but we then needed to injection mold that part.
Right.
So, and you don't just say make a part and then injection mold it, because the molds are very expensive. You got to make sure that the part is exactly right. And that's where 3D printing comes in, where you could potentially have that part made with similar tolerances to, say, an injection mold, especially with some of the technologies that are available now. And then you could do a run and then try out that design. How is it going to work? How is it going to be implemented? How is it going to be put into the thing? Then you're confident in your design. You've gone from the screen, you've got this solid part, you're highly confident. Then you go on and you can spend the money to make thousands of these parts. Yeah.
Awesome.
No, it's a cool project, working with different materials. It's like any project that I get into, I get excited. One of the technologies I got introduced to was a stud welding gun. You ever heard of a stud welding gun? So it's a basically a handheld welding machine, and you put in threaded. So it's a basically looks like a bolt without a head.
Okay.
You put that into the machine. There's a little stud. It uses a capacitance discharge. So it's basically electricity.
Yeah.
So you ground it to the part, you push, it does an impulse of energy and welds that stud basically to anything that's metal.
Right.
So you can make a custom mount of a threaded area coming out. So that's what we went through, and then created these studs all through the part.
Okay.
And then those lights are then mounted onto a component that went onto that stud. But then I learned about stud welding, and I learned that from an art project, and I may now apply that to some sort of architectural or a science project or anything else. And then as we were talking about too, how can you speak to it? Well, I used that welder. We designed parts that went on the welding. We tested them. I can now speak to the strengths and the weaknesses of that, not because I read about it, because we used it. Yeah. And that's what I'm always saying, get experience, use things, pick up things, make things. It's wonderful to watch YouTube videos and to read things all the time. And there's another to be making them. And
you can't beat that hands-on.
Yeah. And nothing is a waste. Just start, if you want to get good at this, first thing, just start making stuff.
Yeah.
Yeah.
So I want to talk about finances a little bit. Well, I was at Rapid not too long ago, and the focus there was metal 3D printing.
Okay.
Which I know you have some experience in, so I'm going to pick your brain on that. But also, basically, like, metal was so prevalent, it almost seemed like money was no object. Now, you obviously have financial limitations for what you can do in your lab, but you also do have some university budgets, and you've done some metal 3D printing. Tell me your experience of what metal 3D printing has been for you so far, and where do you think it will be in the next couple of years? Because obviously it's the center of focus for a lot of companies at Rapid.
It's super interesting technology. I've used it a lot, say within design work. And honestly,
what for?
There's been a couple of, I've even used it, say, within art projects. And where it came into place was we needed to mount something, and it was bespoke. We didn't need 10 of these things. We needed one that had very specific geometries. And it became an idea of like, well, we could metal print that part and create that bespoke kind of custom component to make this structure possible. And it worked quite well for that. It is expensive. But when you look at it, say comparing, especially things like you can 3D print titanium, cobalt, chrome materials, different aspects. You can even print things like aluminum, different levels of stainless steel. Those are kind of more typical things you can print with. You can also go as far as there's printers that I've seen in Europe that can do things like tungsten materials, like these really hard materials to machine and things. It does have its limitations though. There are different ones. We used ones that was powder sintered. I've got a lot of experience doing that. There are the ones, and I can't speak to more, but I've seen some examples of the ones that are 3D printed, say like on an FDM machine with a matrix, which is then put in a furnace. And it just becomes the reliability of the dimensionality of those parts that I've seen, where you're trying to understand, in an oven, X, Y, Z, gravity is always in works. What is the production part? That gets into the computer modeling, the thermal analysis can give you a predictor of how that part's going to turn out. That's a really exciting area, the idea of print and bake apart. It's like cooking, you're baking apart. That's getting better and better. But
it's still fairly complicated right now.
It's super complicated, but you need the computer models.
Exactly. You need that expensive, simulation software to see where all the parts will sinter together and have the stressful forces. But you talk a lot about, limitations of metal. And I think, I don't have a lot of experience in metal at all, and you do. What are some things that people are not even thinking about when they think metal 3D printing? Because right now, all of us think it's just like FDM or it's just like SLS. It's that simple, right?
That's a great question. Like the technology I use is a laser sintered powder that I've got a lot of experience on. You can imagine, so you're basically welding a part back together. There's things like you're adding a lot of heat. The build plate on a metal part such as that is actually a chunk of steel. And so it acts as two things. It holds the part as it's being built, so it becomes your build plate, but it also acts as a heat sink, drawing heat away from the part. You can imagine you could actually overheat a part where it's just too much heat, and then it just works into the idea of you get thermal interactions. You may have to then do an annealing process afterwards where you relieve out all those thermal stresses.
So what happens if it does overheat? Are your tolerances just off dimensionally, or worse?
It could be worse. I've seen certain parts where there was just so much thermal energy. The build plates are actually bolted right onto the stage. So these are large bolts that it actually bent the build plate to the point where it popped the heads off the bolts.
Wow.
There's that much energy that can be within a part. So we're talking large deformations, which can happen. We've all seen it. And in unenclosed ABS, that's exactly the same things that are going on. There's so much thermal,
but just on a more catastrophic level, because
well, that was metal. It's a little scarier, that you're dealing with this metal part. And at the end of the day, it always comes down to surface quality. So say you've got a part, you may need to do you most likely will need to do post machining. So this is the thing that you might have 3D printed, so you don't have to machine the part.
Yeah.
But you can get away with, say, doing that last skim coat. But it's always that thing. There's always going to be the amount of energy and heat. And that is an issue, I think, with SLS too. You've got a lot more experience now. I've ordered a few parts. I've had parts built. But some of the things with SLS that I've heard is trying to control that thermal gradient across the entire build volume. And then if you have too big a part, if the thermal clines are different, you may get warping and distortion, or the part may cooling, maybe it didn't cool down long enough, and you get that bending of a part. And then you figure out one work around that, maybe to make the part thinner, because then you're not getting as much buildup of that energy. It's counterintuitive as an engineer or something. I'll just make the part thicker to make it stronger. Yeah. But maybe that'll get me in trouble in this area if I make it thicker to make it bigger. And so there's that balance. I think we already talked about, there isn't a lot of expertise, say, in this area to even be teaching others about it. So when you get into metal printing, there's even less people that know how
That's why I'm
metal
trying to get
printing
some gold.
works.
I'm getting some gold from you now in terms of
I think a lot of times too, is we see industry as they'll hear about these technologies. And I think we need to communicate better to industry what the limitations are of those technologies, because they may watch, especially something that's on YouTube or flashy showing this thing. We've all seen houses built from 3D printers and things like that. And somebody may think, I'm going to get a house built out of 3D printing. Well, I don't know the limitations of building a house out of 3D printing. I thought it was pretty good the way that we built houses. I didn't know that we needed a 3D printer to do that.
Right.
And the same thing with metal. They may say, well, I can just totally, instead of machining my parts, I'm going to 3D print them, say out of metal. But then you hear about all these things, limitations. You may have to redesign your part. it can get really exciting because you can maybe also do things in metal printing that you couldn't do from traditional machining. We're talking about things like, say the part needs a heat sink or it needs to dissipate energy quickly. You can print impossible cooling channels. You can make the part impossibly thin. You can do all these really exciting things that aren't simply replacing a current manufacturing technology, but is enhancing it or making you think about a new way to build parts.
But it's all about knowing the limitations. And you're very right about this. The marketing videos we've seen, it is that easy. You push a button and you get your metal part. And that's what it looks like, at least, you know, from the surface when looking at some of these videos. But obviously, that's why I asked you that question, in terms of real world experience. There's a lot to learn. It's an entirely different ball game than even just, you know, nylon SLS. There's so much more to learn, and you know, I probably wouldn't even attempt it unless I had another 5-hour conversation with you before getting into that. Which is what would bring me to kind of my next question is, you know, we talked a lot about access and, you know, the coming down of prices and the ease of software coming into play, and a lot more people having access and being able to start learning this technology and having more accessibility to the general public. Do you think that this is something that would happen to some of the more high-end stuff on the market as well? Like, do you think SLS is going to come down in price and metal SLS would come down in price so that we would eventually be doing some metal ourselves? Or what is your, I guess, a little bit of prediction for the future, maybe 5-10 years out?
It's a great question. I think, yes, I think in scale and marketability, we've seen such shocking. I honestly, I stayed away. We had commercial printers for a long time, and I stayed away from the hobbyist market kind of when some of those patents came out and we saw the hobbyist market kind of start up. I always said, you know, as a designer, I want a tool that will make me my part. I don't need another project. And I think some of those early printers were projects. And I think that's an important thing to say. There's still printers that are on the market that may be just a few $100s. Buyer beware, because maybe you need to be kind of a semi kind of maker pro. You maybe need to know a little bit of electronics. You might even need to know a little bit of coding to make that machine work quite beautifully. Some of the commercial printers, they don't want to deal with that. You just hit the thing and it's going to make you the right part. Sorry, I've forgotten further what you were kind of
in terms of like seeing the outlook of, you know, going down in price and increasing of accessibility. What do you think that'll be?
I think we're going to get there. I think there's even the idea of the laser cutters and where those have come down in price and the different technologies they're using. I think I'm really hoping the SLS market will be the same way. There's a lot of amazing technologies that need to happen in there. But you do see some of these, maybe someone doesn't need a giant build volume. As we said, a lot of making things can potentially be much smaller parts. It's easier to control the thermal space of a small build volume than it is a large one. And so maybe that would bring down the cost. So we may see more of like a desktop, small volume printer, which would be the first one that maybe hit the market. Again, I'm not sure where we're at if some of the limitations are also licensing. I can't remember if all the patents are done with SLS. That might be an aspect of it too. Certain technologies may simply have certain patents that haven't come up yet. So that's holding back potentially why we're not seeing a proliferation of a certain technology to that kind of lower price market. So
in terms of you personally, and maybe, you know, some of the projects that you've worked on or some of the students that have come to you, you know, what do you think now is still a barrier? Is it still just the learning of software, or is there some technology that would change things for you, that would make things a little bit different? Like, do you still have complaints about dimensionality for some technologies? Like, what are your complaints that we think we should address in the next couple of years that would change things for you?
It's a great question. I think there's different levels. Say on the high level, like, you know, product development, industrial development, I think we've got some really great tools. The fact that you can now get an SLS machine for 5 figures, it's kind of pretty awesome. You know, I think that's going to change things. I think within the educational component of, say, a maker or a creative person, I think tools available right now is like no other time. The level of software that's out there, I think it's also understanding what are the right packages to get to know. There's, I've seen it done, especially some of the school systems, they use the most basic package. And I don't know about you, but young people typically aren't held back by their brains are like sponges. They can actually handle the tough stuff. And I think I'd like to see that done more, is the more complicated kind of software programs introduced at the elementary school than say some of the really basic programs.
Get them started.
And I'm not going to mention them, but some of the
yeah.
basic programs that have been out there, and I'm like, yeah, you can learn that tool, but it's so limited. And if they only learn that one, which may be a higher level of investment, they can basically go work for a manufacturing facility afterwards, which I think, we talked about the idea of importance of coding and school and all that stuff. That's pretty awesome. If they can learn a coding program, which is then can maybe get them an opportunity or make them useful for the industrial space, that's pretty awesome. And generally the idea is students, given the right resources, I think that's not the limitation. It's a tough question. How do we teach this stuff? How do we get people interested in it? But you meet someone who's highly creative, and sometimes you just give them experience, access to the tool, and that may be enough to set a fire to get them going. That whole idea of, just as a side, we had it was a few years back, I had a grad student who did these really awesome plywood designs, like these intricate designs out of 2D wood. And she would use a jigsaw, and it was quite laborious. And so to make something was quite an investment of time and all the labor that went into it. And I remember we went through CNC machining with her. So she learned how to do the machining track. And it was almost like we didn't want to show her the laser yet because so she really embraced it because she saw that if she learned these tools, she could bring her ideas to fruition so much quicker, and she could do more because the machines would take care of certain things which were highly time intensive, and the machine could actually do it better than her. And then we showed her the laser, and it was just like building parts all over the place. But it was really kind of interesting. Someone that was kind of not very interested in that technical space had chosen to stay away from the engineering or the math side of things. But we kind of got her, it's almost showing, if you learn this software package, and it's not going to be painless, it's repetitive, you got to keep doing it over and over again, learn where all the tools are, all those things. But once you get that comfortableness, then you can really kind of fly. You can really kind of do things. And that was enough. You kind of show, if you do this, this is what you get.
Yeah.
And that was enough.
She was like, it's worth it.
It was enough to tantalize her. And I think it changed her workflow going forward.
I think I answered my question a little bit because the way to get students interested and to learn more is to talk to people like you and kind of be inspired by your passion for this craft and this discipline, so much that they're like, yeah, it's not that scary, right? Like, if you can do it and you can teach me how to do it, I don't need to be scared. I can pursue it, and then they can grow. Now, if we proliferate this, a couple years down the timeline, and you were very successful at this, and you converted a lot of students, and things were to change, what kind of things do you think would change in our industry? Are we going to have students come out that are prototyping experts? Like, how would that industry change now that we have all of these tools? There's more and more of this in schools. You said that there's more hands-on so that people can get the experience for software and hardware so that they can eventually just come into a manufacturing job. So should manufacturers change the way they look at hiring? Is there a job opportunity that we haven't created yet that is like a prototyping engineer, prototyping expert, or is that something that we already have that's just augmented by 3D printing? What do you think about that?
Interesting. It actually made me think of something too, is almost when we talk about future proofing. So not only what these skill sets maybe could bring into industry, but also brings the skill sets that the person is getting and what that can do for them later. I recently heard a podcast from an individual that was talking about when there's economic downturns or things like that, the best way to weather that storm, one of the ways is to invest in yourself and your skill sets. And I firmly believe that these are strong foundational skill sets, which are useful. And I'm not sure what will happen if we can create more people that can be designers and builders and things like that. But as I say that too, I need to be reminded, I have people in my life, they don't care about this at all. And that's okay. This isn't for everybody.
Right.
But what I have noticed is those that are particularly creative and like to build things and do things, showing them how to use these tools is almost like, it's fun. They lighten up.
You can see it go.
I've worked with so many, and I come back to artists, and what it is that you can have engineers, designers, artists, that whole group together. I still say it's just a creative group. We don't need to name it. We should just say those that are creative.
Yeah.
But even within that, you show them a tool and then you see where now they maybe have limited their creative abilities because they think, oh, I can't do that because I can't build that. Or how would I ever make that? And then you show them these whole other things. It just opened up a whole other side of the world.
Yeah.
Oh, I can do all these things. And because this is now I know how that you can make things. And I think that can only be beneficial to a society. But again, sure. I think there's this idea, we're going to make everyone a designer. No, it's not. The world is made up of totally different personality types, people that want to do different things. Not everyone is a creative person or an artist. And last thing I want to do is have that person forced to do these things, because I think that's also not good as well. But it's getting the tools to the people that really want or would find some sort of enjoyment, I believe.
I think, with COVID in the past couple of years, people might have some extra time on their hands. And if they picked up a tool, they've probably got their hands on, but they probably now need a little bit of guidance in terms of, hey, where does this lead me? Is this just a hobby? Could I eventually get a manufacturing job if I keep pursuing this? I think that's blurred the lines a little bit. We've got a lot more people who are now designers, and, they don't consider themselves an engineers, but they could probably, pursue that as an avenue and discipline a little bit more than they, thought before COVID if they didn't get into buy a printer by accident because they were bored. I think that opens up a lot of things, in terms of my mind of potential students and kids, just learning technology because now it's accessible. It's not overly expensive, but I still think they need that guidance. And, that guidance could come from someone like you, or it could come from community programs and things like that. And I think that would really lead kind of a mini revolution in terms of, knowledge and not being so scared of manufacturing, because, as kids growing up, manufacturing is an adult thing. Yeah. Like if you're not an engineer, how would you get into manufacturing? I think that's a big mental barrier, at least, my generation, I have. So, how would we get past that? But I think now with the tools that we have, it's a lot less scary. Do you see that, happening, or is it different? I mean, you see a lot of students. Are they less scared of manufacturing? Is that, kind of a thing that we talk about now more because supply chain is an issue? I think it's even with as much information as accessible now, I think there's still a huge amount of ignorance. And what I mean by ignorance is lack of knowledge in that area of what is involved in manufacturing. And even at my level, how they make certain parts or things like that, I'm always trying to figure that out. And I think it's better to kind of show what a person would be doing in that field, but also then I think within industry, show what that person could do for your company. I think it's a tough question to answer because I think we're still, there's advantages which can be delivered to certain companies with these technologies, but we need to help them guide that path to how these technologies can be used in an advantageous way. You bring up an interesting point, which is like the top of the company also needs to recognize the benefits of bringing some of this technology in, and a lot of times change is scary. Change is scary. A lot of companies are risk adverse to maybe trying new technologies. One is maybe you'll sink a lot of time, which people could be working on something else. The other one is you could buy a piece of equipment that becomes a paperweight. And that is a lot of times I've seen with 3D printing, especially when the printer itself, it's almost, if you're purchasing a printer from somewhere and you're not the most technologically handy person, it really is nice if that company can help service that. Yeah. Because that's the last thing you want is, a lot of these things are fixable, you just need help guidance through that roadblock of what's happened to your equipment. But I get it. But it's also then showing, I look at it and go as a designer, there's nothing more satisfying than working on something, being able to in-house produce the part and then have that part readily available. And maybe service bureaus, I know there's certain areas in the States where they have huge warehouses full of pieces of equipment. Next, you can pay a premium, but you can get almost next day or second day delivery. Yeah. So that is pretty much almost like having the equipment in-house. Yeah. If that gets more accessible to that kind of rapid turnaround, if it's just a couple of days to make parts, I think that'll be truly revolutionary too. Yeah. Because then you got companies that are investing in all the latest printers and technologies and all those kinds of things. Yeah. There's a lot of growth in a lot of areas. Yeah. Yeah. I think it's a great time to wrap up. And I guess a 3D printer is only as powerful as the person who wields it. If they have that knowledge, that experience, the guidance, then they're going to be doing great things with it. Thank you so much, John.
No problem. It was great talking to you, Ken. I really appreciate the opportunity to kind of talk about this subject.
Thank you.